Kia ora Year 12 and Year 11. This video is mainly for 13 MCA for some start of year revision of the AS content, but it might also be useful for 12 MCA for Year 11s later on in the year. So what I'm going to do in this video is go through the June 2021 exam paper, and it's paper number 13, and that's out of the series code 9709 as usual if you're looking for it. Probably going to split this into about 4 or 5 videos because I'll get through about 3 questions per video so that they don't get too long. So in this one, we're going to start at the start. The first question is a very straightforward little 3-mark one, and then the next one is looking at the idea of what is a decreasing function. And the third one is the most interesting. So there are 2 ways to do that. So pause the video now while you're on the screen and give yourself some time and just work through those questions first, and then I'll go through them. Okay, so question 1 is a straight up calculus one where we're given the equation of the gradient function and we're told that it passes through this point here. So let's work through that now. So f of x is going to equal something x cubed, and it will be 2x cubed. We can write the gradient function, and I should have done this first, with a negative power to make it easier to differentiate without mistakes. Okay, so working backwards, I'm going to have minus 8, and then I'm going to have something times x to the negative 1. Now, when I differentiate, that negative 1 is going to come down, so I need to undo that by dividing through by negative 1. If you're watching this, that should be pretty familiar, but it's a really easy place to go wrong. So whenever I'm doing differentiation in these videos and anti-differentiation, I'm going to go through that reasonably slowly. Okay, so cleaning that up, we get 2x cubed plus 8 over x plus c, and we can check that back and see that we do in fact get to this. The last thing that I've got to do is substitute in that 0.27, so we get 7 is equal to 2 times 2 cubed plus 8 over 2 plus c, giving me 7 is equal to 16 plus 4 plus c, which leaves us with c is negative 13, and the original function is 2x cubed plus 8 over x minus 13. Okay, so there you go. That's the first 3 marks of the paper done. Let's look now at question 2. So question 2 is another calculus one, and we're told that we've got a function, and this is the function here, so not very easy to graph. And the function is defined for x values between 1/2 and an upper limit of a. F is a decreasing function. So a decreasing function is one where everywhere the gradient is negative. Okay, I just want to go over this in case anyone's watching this for level 2 or 3 NCEA. If we've got, say we've got a function like this, then we can identify places on that function that are decreasing, right? So for example, here the function is decreasing, right? And here the function is decreasing, and it looks like over here it's going to be decreasing. But what a decreasing function is one where everywhere the function is decreasing, and that's what we're dealing with here. So I'll just get rid of that bad graph. That means that this question is asking us to find the gradient function and then figure out where it's negative, and that's going to give us an upper limit. So f dash of x will equal 1/3 times 3 over 2 times 2x minus 1 to the power of 1/2 times 2. And that's using the chain rule, so then take away 2 for that last term. So just going over that again, I've got to do the chain rule on this because 2x minus 1 is a function of x. So this is what I call the inside function, and that's why we've got this times 2 in here, right? I've got lots of other videos on the chain rule if you've forgotten how to do it. So cleaning this up, first of all, we need to state that it has to be negative for a decreasing function. And now we're going to do some simplifying. So the 3's simplify away, and so do the 2's. We're left with this condition. The square root of 2x minus 1 is less than 2. Now, we already know that this is going to be greater than 0 because the function's only defined where x is greater than 1/2. So we don't need to stress too much about that. We can square both sides, and we get 2x minus 1 is less than 4. 2x is less than 5. And x is less than 5 over 2. But in the question, we were asked to find the maximum possible value of the constant a. So this is saying that when x is less than 5 over 2, and also x has to be bigger than a half, then the function has a negative gradient. So that means that the maximum possible value of the constant a is 5 over 2, right? Because if I picked anywhere lower than that, it would also still be decreasing. That's quite a common Cambridge question format, so just kind of make sure you're used to the logic of that very last step, that we're finding the maximum value of a. Now on to the third question, and the most interesting one. We've got a line with this equation. So a straight line where it's got some gradient, m, and it's got a y-intercept of -6, and it's tangent to the curve with this equation. So we're going to draw that in a minute. That's a pretty easy parabola. We have to find the possible values of the constant m and the corresponding coordinates of the points at which the line touches the curve. So I've got a graph of this. Nope, that's the wrong graph. Here's the graph of question 3. Right, so we've got y is equal to x squared minus 4x plus 3, which is just a parabola that can be factorized as follows. And what we're looking for is the two places where we've got a tangent from -6. So you can see that there's something going on if we do one really high up like this. Let's see if we can draw that in. And then there's going to be another one somewhere over here, right? And so just from looking, you can see where they're going to come out. Now, I'm not expecting that in the exam that you would draw that accurate a sketch, but I'm trying to show you that drawing a sketch is always, always a good thing to do when you can do it. So in here, there are two different ways to do this question, right? So the first way is to think that at the 2 points, we know that the y values must be the same. So just hopping back to this here, we can see that here, where the line is tangent, the y coordinates and the x coordinates are going to be the same on both curves. So we can use that, right? Because that will let us get a solution for x. So I'm going to do that way first, and then we'll look at the other way. Right, so we know that dy by dx for the function is equal to 2x minus 4. So here's my badly drawn graph. So we'll call these points A and B. So at A and B, we know that the slope of the curve is equal to m. We know that 2x minus 4 is the same as m for that tangent line there. And that means that we can substitute this into here and then equate the y values. So 2x minus 4 times x minus 6 will be equal to x squared minus 4x plus 3. Now that's only going to work at those 2 points, right? But it will work there. This is going to give me a nice quadratic to solve. So we get 2x squared minus 4x minus 6 is equal to x squared minus 4x plus 3. X squared minus 9 equals 0. X is going to be either 3 or -3. So we're asked to find what? We're asked to find the coordinates of the point. So we've got x, now we need to get the y values. So the y values at x equals 3. What's y? Well, y is equal to x squared minus 4x plus 3. So that's 9 minus 12 plus 3, which gives me 0. So the first point is 3, 0. And then we can do the same thing for x equals -3. We get y is equal to 9 plus 12 plus 3. So the point is -3, 24. Now what about m? Well, m is pretty easy. M is just 2x minus 4. So m is equal to 2 times 3 minus 4, which gives me 2. And the line is, I don't know if we were asked for this, but the tangent line will be y equals 2x minus 6. Similarly, for m over here, we've got a gradient of 2 times -3 minus 4, which is -10. And the tangent is y equals -10x minus 6. And you can see from looking, so I'm going to show you a graph that I've done with the end. You can see that that's exactly right. Okay, so that's the first method, and that's one way to do it. For those of you who have been working through the AS syllabus, you'll know, though, that there's another way to do this, which is kind of cooler, which is using the discriminant. And I'm going to do this using this graph that we've got at the end here to see what's going on. Right, so we've got the curve and the line touching at the place that's our solution. And if they're touching, that means that that line, that red line, is just giving us there's just one solution for where is the red line equal to the quadratic, right? So we've got the curve, which is y equals 4x, x squared minus 4x plus 3, and we've got the line. Now, we know that to be where we want to be, that we're only going to have one solution to that equation. Now, think about why that is. Well, suppose that we had no solutions. Well, if we had no solutions, we would be in this situation, right, where the line just didn't touch. And if instead we had this and we had two solutions, that's not what we want either. So one solution only is what we're after. We've got a quadratic, so one solution only means the discriminant must be 0. So I think for most of you, this is probably the way you did this question, because once you've got the hang of this method, I think it's a really nice way to think about it. So we've got x squared minus x into 4 plus m plus 9 is equal 0. So one solution. So because it's one solution only, we need the discriminant equals 0. So what's my discriminant in here? Now just be careful with this factorising bit here. It's an easy place to make a mistake. So b squared minus 4ac is equal to negative 4 plus m squared minus 4 times 1 times 9. That has to equal 0. Expanding this, well, the negative squared gives me a positive, so that vanishes happily. So we get 16 plus 8m plus m squared minus 36 equals 0. So you can see this way of doing it is going to let me solve for m first. So we've got m squared plus 8m minus 20 equals 0. That gives me m and m plus 10 and m minus 2, giving me my two solutions. So how cool is that, right? So we get m is negative 10 or m is equal to 2. And now we go back and we have to figure out the x coordinates, right? So for my first line, I've got y is equal to negative 10x minus 6. And for my second line, I've got y is equal to 2x minus 6. Right, now we still need the coordinates for those. Now you can see them because I've done a really lovely GeoGebra graph. But if you can't see them, then you have to go back and solve. But you end up with a really easy quadratic. So lots and lots of quadratics in this exam paper. So we've got 0 is equal to x squared plus 6x plus 9, which is giving me only the one solution for that one because it's a perfect square. So we get x is equal to negative 3. We take that and we chuck it into there. So y works out to be 30 minus 6, which of course is 24. So that gives me negative 3, 24, and m is when m is equal to negative 10. Doing the same thing over here, I get 2x minus 6 is equal to x squared minus 4x plus 3. 0 is equal to x squared minus 6x plus 9. So you're looking for a perfect square here, right? Because you know you're going to get one answer out of this thing here. So 0 is equal to x minus 3 squared, giving me x equals 3. Substituting that into there now gives me y is equal to 6 minus 6, which is 0. So we knew that. Okay, very long video. Thank you very much. If you are still watching, if you could email me and tell me which way you did this, if you're in my class, or leave me a comment if you're not. I am curious about how you attack that third question. Thanks for watching. I'll try and do the rest of the paper over the next couple of days.